Right, sorry, scrabbling around from my protractor. Bearings question. So a ship on a bearing of 215 degrees from Holyhead and on a bearing of 324 degrees from Cardigan. By drawing suitable lines, mark the position of the ship. So you need to remember that bearings are always measured with 0 being north, so from north, and they're always measured in a clockwise direction. So we're going to line the centre of the protractor up with Holyhead. We're going to put line 0 up with north, and we're going to measure 215 degrees. And again, my little check to make sure it's going to be sensible, 215 degrees is bigger than a straight line, bigger than 180. So I'm expecting to go around further than to south. Okay, so it's going to be around there. So 215, so we've got on the outside of the scale 0, 10, 20, 30, 40, 50, 180, 210 is there, 220 is there, 215 is the long one marked between. So I'm going to put a mark there, and then you join that. Now you've got no idea where on that line yet the ship is going to be, so you just mark it in, and then just to show the examiner you know what you're doing, mark that there as 215. Then the second is a bearing of 324 from Cardigan. So now we're moving the centre of the protractor to Cardigan, lining the 0 up again with north, and we're going around to 324. And you can see same direction, so we're using the outside scale, 310, 320, 324 is there. So the line's going from Cardigan through the dot I made, and make sure it crosses the line, and that is where C is. So again, show the examiner what you're doing, 3 to 4 degrees, and that's where the ship C is. Now the marks for that, question 12, there's one for the bearing, one for that bearing, and one for the correct joining up of the points. Question 13 is a trial and improvement question. So if you want to practice those, there are some on the foundation and I think the higher tier part of the Jones & Son website. And what I've shown you on those practice ones to do is to use your calculator again to help you. Okay, you can put things into your calculator exactly as they are there. Now if it lies between 2 and 3, the first thing we do is go halfway between so we can eliminate most. So we put x when x equals 2.5. So we're going to put in our calculator, wherever there's an x we replace it with a bracket. So we're going to do 2.5 cubed, take 7, 2.5, take 2 equals. So we type it in exactly as we see it. Open bracket, 2.5 close bracket. Now we haven't got a cube button, but we've got this x blob, and that blob means that can be any power you want. So that is going to be to the power of 3. Move your cursor down, take 7, and instead of x we open the x out. Okay, if you see we've got an x which looks like that, it's just 2 brackets that we put the other way around. So we open the x out and put 2.5 in, take 2, so it's exactly the same as it says there, and we can see there that that's negative. So we're looking for a value which is 0, that's smaller than it, so 2.5 is too small. So there's no point me trying 2.2 or 2.1 or 2.4, because they're going to be too small as well. So I'm going to go now, my answer is going to be somewhere between 2.5 and 3. So so I pick a number again, and to eliminate the most, I'm either going to choose 2.7 or 2.8. So when x equals 2.7, 2.73 minus 7, 2.7 minus 2 equals, so same thing again now, open up the x, 2.7 to the 3, take 7, open bracket, 2.7, take 2, equals, still negative. It's getting closer though. So now answers between 2.7 and 3. So I'm going to try 2.8 or 2.9. I'll try 2.8. So 2.8 cubed, open bracket, 2.8 power 3, take 7, open bracket, 2.8, take 2. It's positive. Okay, 0.352. Too big. That's bigger than 0. Okay, so that means x is between 2.7 and 2.8. Now I want my answer to one decimal place. So one of those is going to be my answer. I just have to decide now which one to decide which one is going to be. So to decide which, we choose x halfway between 2.7 and 2.8, which is 2.75. Think halfway between £2.70 and £2.80, £2.75. Bracket 2.75 cubed, take 7, 2.75, take 2 equals, open bracket, okay. Now that is a very, very small number. All right. Oh, that's because I put it in wrongly there. Look, I haven't come down from the power, so it's got a very. So we'll do that again. That's me going wrong. Try it again. 2.75 to the power of 3. Bring your cursor back down. That's a mistake I made. Take 7, open bracket, 2.75. Take 2. That's better. So minus 0.45. Okay, so that's too small. So if that's too small, everything below it is too small. So the answer is closer to 2.8. So x is between 2.75 and 2.8, and everything between there and there rounds to 2.8. Because that's the only, however far you need to go, was one decimal place. So the marks for that there's 1 mark for plugging in and working out anything. There's 1 mark for going a second time. And then there's 1 mark for your decision and 1 mark for the answer. So you've got 2 marks for zooming in to 1 decimal place, then 1 mark for your method of deciding which one of those is going to be, and then 1 mark for getting it right. Question 14. Table below gives information from the highway code on stopping distances for cars. So you've got stopping distance in meters is the thinking distance plus the braking distance. So the thinking distance is how long it takes for your brain to change what your eyes see to being able to put your foot on the brake. And then once you put your foot on the brake, that's how far it takes you to stop. A warning sign for a crossroad is to be placed on a road which has a speed limit of 30 miles an hour. So that's that row there. Use the data given above to find the minimum distance that the warning sign should be placed from the crossroads. So it's going to, as soon as somebody sees the sign, it's going to take them 9 meters to process it in the brain, and then 14 meters to stop. So the minimum distance it has to be away is 23 meters. Should be a bit further, but that's the minimum. An average car is approximately 4 meters in length. How many car lengths is the stopping distance for a car traveling at 40 miles an hour? So at 40 miles an hour, stopping distance is going to be 12 and 24, which is 36 meters. So how many cars will fit into 36 meters? So number of car would be 36 divided by 4, which is 9 cars. So for that you got 1 mark for that, and 1 mark for the adding up and dividing, and 1 for your answer. Complete the table below. So this is a conversion table taking miles per hour to kilometers per hour. So just like if you were converting a recipe from 5 people to 8 people or something like that, you need to work out what the scale factor is. So to work out what the scale factor is, what do you have to multiply that by to get 80? So you would do 80 divided by 50, which is 1.6. So going that way, you'd be multiplying by 1.6. So 30 times 1.6 is 48. We've used that one. So to go backwards, we're going to do the opposite of times it by 1.6, which is dividing by 1.6. So you do 112 divided by 1.6, which is 70. So you can have 1 mark for working out the scale factor, and then 1 mark for each of the other values. The stopping distances given in the highway code are given assuming good driving conditions and alert drivers. When a driver is tired, the thinking distance increases by 30% and the braking distance increases by 20%. Calculate the stopping distance in meters for a tired driver travelling at 50 miles per hour. So thinking at 50 is 15 meters. So new thinking. So the thinking distance increases by 30%. So we're going to do 30% written as a decimal will be that times 15 equals 4.5. It's going to take 4.5 meters longer to process in the brain. So the total distance for the thinking is going to be the 4.5 plus the original 15, which is 19.5. Then we do the same for the stopping, but for stopping it's 20%, so 0.20 times, and now that's 38 meters. So So we do 0.2 times 38, which is 7.6. Then we have to add that on to what it was before. So you get 45.6. So the total stopping distance, so that's braking distance, is going to be 19.5 plus 45.6, 65.1 meters. Okay, so the marking for that, you get 1 for working with percentages, 1 for the 19.5, 1 for the 45.6, and 1 for the 65.1. Question 15. Okay, so we got an electricity bill to deal with here. Quarterly statement from Welsh Energy is shown below. Some of the entries have been removed. He pays for his electricity by monthly direct debit payments, and he gets a discount of £27.50 for paying by direct debit. Okay, so the first thing to do is to get everything in pounds. So we're not going to work with 26.5. We're going to write that as, if it was 26 pence, it would be that. So 26.5 pence is that. Okay, so everything we're going to deal with is in pounds. Last time his meter was read, it had that many units on it. Now it's got that many. So the units used will be 4921 take 4267. So 4921 take away 4267 equals 654 units. So the amount he has to pay for the units, so cost of units will be the number he's used times how much each one costs him. So he's used 654 and each one costs him 26.5 pence or 0.265 pounds. Sorry, 654 times 0.265. So £173.31 is how much the electricity that he's used costs him. So if we transfer that back up here, that's going to be 654, and that's going to be £173.31. On top of that, regardless of how much he's used, he gets charged £30.45. So we're going to add that on. It's £203.76. He then gets charged 5% of the total charge for VAT. So VAT will be 5%, which we write as a decimal, 0.05, and we times that by £203.76 times 0.05, £10. Now we're working in pounds, so we round. 2 decimal places is pounds, so it's either going to be £10.18 or £10.19. We use the next digit to make a decision. The next digit means it's closer to £10.19. So VAT is going to be £10.19. Now he's already in credit in his account by £42.36. So that is going to come off what he has to pay because it's already been paid. So the total to pay is going to be, and you have to be careful here. I've seen so many of you where you've added them all together again. That £203.76 is already what those are added up. So what you're going to do for total to pay is just the total charge, £203.76, plus the VAT, less his credit from the previous quarter. So you're going to do 203.76 plus 10.19 less 42.36. So he's got a bill of £171.59. But because he pays by direct debit, he doesn't have to pay that in one go. He pays so much a month ready for the bill. He gets a credit for direct debit so that it comes out automatically. The electricity company don't have to be chasing for it. So that comes off what he owes, and each of these £55 come off what he owes. So now we're going to do £171.59 less £27.50 less 55 less 55 less 55. So that means that he's actually paid more than he needs to. So that becomes credit, i.e. £20.91 credit to be carried over to the next quarter. Okay, and that's how this works, because you know, in the summer you'll run up a lot of credit because you won't be using as much electricity, but then in the winter, where you've got all the heating on and whatnot, all the lights on, then your electricity for that quarter tends to be higher. Right, marks for that then. So you get 1 mark for the 654. You get 1 mark for the £173.31. You get 1 mark for the £203.76. You get 1 mark for the £10.19 and 1 mark for the £171.59. So even if you were getting a bit of a knot with all the credits, you've actually got 5 out of 6 for getting down to there. And then finally the last mark is for that. So long as you think carefully, and the most important thing of all is you get shot of that pence cost straight away and turn it into pounds, then you should do okay. It's keeping that in pence is where the confusion comes in. And then the final question. We've got a right angle triangle. We're in the foundation paper, so we don't have to worry about trig. The only thing we are required to know about right angle triangles is Pythag. As soon as you see a triangle with a right angle that you know 2 of the sides, square those sides. Automatically square them. So you do 4.1 squared, which is 16.81, and 8.6 squared, which is 73.96. Don't worry about when we're going to use it, just as an automatic trigger, square those. Right, calculate the area of the triangle ABC. Area of a triangle, nothing to do with squaring those. In order to find the area of a triangle, it's base times the perpendicular height. The perpendicular, remember, means at right angles. So the area is a half times the base, 8.6, times the perpendicular height, which is 4.1. You need to know that formula for the area of a triangle. You're not given it. So half base times perpendicular height. You can type that into your calculator exactly as you see it. Half times 8.6 times 4.1 equals 17.63, and it's not telling you that you have to give the units, but it's a good habit to do so. For area, it will be centimeters squared. For the perimeter, remember that perimeter is the distance around the outside, the total distance around. So if you started at B and walked all the way around the shape, the total distance that you've travelled is the perimeter. So in order to find the perimeter, I need to know the distance AB. So this is where Pythagoras comes in. You know two sides, you have to find the third. And you know it's going to be to do with the squares. All you need to decide is whether or not you have to add those squares or subtract them. If the side you're trying to find is the hypotenuse, which is the longest side opposite the right angle, then you add them. If you're trying to find a shorter side, you subtract. So here I'm trying to find the hypotenuse, so I'm going to add them. So AB squared is 16.81 plus 73.96. We've already done the squaring. That was the first trigger. So I got 16.81 plus 73.96, which is 90.77. That's what the square is, because we're working with squares. So I need the length, so I have to do the opposite now of squaring, which is square rooting. So square root, type it in again, or just say ants, because it was the last one on the screen. 9.52, that would round to 9.53, but I've only got one decimal places on the go, so 9.5 is good enough. So the perimeter of my shape, I now know that that's 9.5 centimeters. So the perimeter is going to be 9.5 add 8.6 add 4.1. Which is 22.2 centimeters. And there's a final sting in the tail here, which says they want the answer correct to two significant figures. Now, significant figures are the ones that are in the most powerful place value wise. So that's in the tenths column, that's in the units, that in the is in the tens. So to two significant figures, it's either going to be 22 or 23. And because it's 0.2, it's closer to 22. So this is 22 to 2 sig fig. Now we tend to practice more with decimal places in significant figures, so that's something that doesn't crop up very often. Right, so marks for that then. 1 mark for half base times height and writing out the maths, and 1 mark for your answer. And then for this one, you're going to have 1 mark for the Pythag method, 1 mark for getting 90.77, 1 mark for square rooting it, and then 1 mark for the method of finding the perimeter, and a final mark for rounding to two significant figures. So that's that paper.